Human experience of time is not fundamentally discrete, though certain underlying neural processes exhibit discrete characteristics that the brain integrates into a predominantly continuous subjective flow. This distinction arises from the interplay between objective sensory input, neural mechanisms, and phenomenological awareness. Neural and perceptual mechanisms. Sensory systems process information with varying temporal resolutions. For instance, the auditory system can detect non-simultaneity between stimuli separated by as little as 2^3 milliseconds, while visual and tactile systems operate on scales of tens of milliseconds. Temporal order judgments, distinguishing which event occurred first, typically require intervals of 20–60 milliseconds. These findings support the concept of a functional moment, a brief temporal window during which events are treated as co-temporal for binding features such as color, shape, or location into unified percepts. Empirical evidence from psychophysics and neuroscience indicates that conscious perception may involve discrete updates. Proposals suggest perceptual frames on sub-second scales, often around 100–400 milliseconds, where the brain constructs snapshots rather than sampling continuously. Long-lasting postdictive effects, where later stimuli retroactively influence the perception of earlier ones, further align with models in which extended unconscious processing, with high temporal resolution, precedes discrete moments of conscious awareness. In this two-stage framework, the brain integrates information quasi-continuously at an unconscious level before packaging it into conscious percepts. Rhythmic brain activity, such as gamma oscillations, as 40 Hz, or alpha-theta bands, has been linked to these temporal integration windows. However, the temporal resolution for full conscious cognition often exceeds 120 milliseconds, and macroconscious frames, encompassing bound, multimodal experiences, may span up to 500 milliseconds. Phenomenological continuity. Despite these discrete elements, human experience subjectively feels continuous, a stream of consciousness or specious present that extends over seconds rather than isolated instants. Philosophers like Henri Bergson emphasized durée réelle, real duration, as an indivisible, qualitative flow, contrasting with the spatialized, mechanistic segmentation of scientific time. The brain reconstructs continuity from discrete sensory packets, much as a movie's rapid succession of frames, typically 24–60 per second, produces smooth motion through persistence of vision and neural smoothing. Time consciousness integrates short, non-conscious functional moments into longer, field-like, experienced moments that encompass change, succession, and flow. This extended present is not punctate but dynamic, allowing awareness of duration, emotional progression, and narrative coherence. Variations in subjective time, such as time flying during engaging activities or dragging under stress, further illustrate that perception reconstructs rather than directly mirrors external intervals. Fundamental nature and limitations. At the physical level, whether space-time itself is continuous or discrete remains unresolved in fundamental physics, e.g., quantum gravity approaches sometimes posit granular structure at Planck scales, far below neural timescales. Human experience, however, operates on vastly coarser scales, milliseconds to seconds, rendering microscopic discreteness irrelevant to phenomenology. The brain's distributed networks, involving the prefrontal cortex, basal ganglia, cerebellum, and insula, construct time perception indirectly through changes in events, interoceptive signals, and memory, rather than via a dedicated time sense. In summary, while neural processing and conscious access display discrete temporal structuring, facilitating efficient binding and updating, human experience as a whole is not fundamentally discrete. It manifests as a seamless, flowing awareness synthesized from these elements. This hybrid character resolves apparent contradictions between empirical discreteness and lived continuity, underscoring the constructive role of consciousness in temporal perception. Further interdisciplinary research in neuroscience, psychology, and philosophy continues to refine these models,